Hi everyone, this is Siajoji. In this video, I would like to explain how to calculate the rate of change problems by using the chain rule for IGCSE students. Okay, let's get to it. First of all, I would like to write down a chain rule, which is dy by dx is equal to dy by dt into dt by dx. If we are finding dy by dx, you have to start with dy and end with dx. So we have to start with dy here and end with dx here. And this t will be same. You can also use a, right? You can use anything you like, but this should be the same. Okay, so that this is the chain rule. So we're gonna use this for calculating rate of change. So I'm gonna write down dv by dt, and I'm gonna tell you the meaning of this, which is rate of change of volume. So because the volume is changing with time, that's why they say time t is time. So this is the rate of change of volume. Okay, if it is dA by dt, it will be the rate of change of area. Okay, and then what about dH by dt? It will be rate of change of height or depth. Depth is also height. Okay, and another one is they frequently ask is dr by dt, which is the rate of change of radius. Okay, so that's the meaning. If they say rate of change of volume, the volume is changing, blah blah blah, so you have to do that dv by dt. If they say the area is changing, so it will be area dA by dt. And like they also say rate of change, or they say sometimes rate of increase, rate of decrease. Okay, so all are the same thing. So okay, now I'm gonna explain how to use chain rule to find these. Let me erase. So let's say we are trying to find dA by dt, the rate of change of area. So how we use chain rule is dA by dr into dr by dt. So this is differentiation of a with respect to r. Okay. So and then if you times it, you get dA by dt. Right? These two will be cancelled out, right? The same thing. Or like you can also do with height, dA by dh into dh by dt. No, the same thing. Or how about dv by dt? dv by dt also you can do dv by dr times dr by dt. That's how you find the rate of change of volume. Okay, and you can also use like height. You know, if you don't want to, if the problem is not doesn't say radius, if it says height, you have to use height. dv by dh into dh by dt. It's the same thing. Okay, so now let me explain some examples, then you understand more. So the first example I want to explain is let's say the volume of a liquid in a container is 3 cm3 when the depth of liquid is h centimeter. The liquid is added to the container at a rate of, they say rate, right? Rate of what? Rate of volume or rate of area? Let's see, 36 cm³ per second. So cm³, which is volume. So they are talking about rate of change of volume. Okay, so I'm gonna write that down. Rate of change of volume is, as I explained earlier, which is dv by dt. So which is 36 cm³ per second is dv by dt, which is 36 cm³ per second. Okay, and the next one they say is given that V is equal to 4h³. So V is equal to 4h³. I'm gonna write down. And then they ask what the rate at which the depth of liquid is increasing. So they are talking about depth. Depth means height, right? So rate of, they say rate. So rate of height, which is dH by dt. So what we are trying to find is dH by dt, and volume is given. Volume is 500. Okay. So let's start with the formula. Chain rule, dv by dt is equal to dv. I'm gonna use h here because they are talking about h. dv by dh into dh by dt. Okay. So dv by dv by dh or dv by dt is here, which is 36. and dv by dh we don't have that. So which is derivative of v with respect to h. You have to differentiate v with h. So v is here. So v is equal to 4h cubed. I'm gonna differentiate with dv by dh. Okay, so which is you haven't learned differentiation. If you haven't learned differentiation, you can go watch my video clip 4 and 5, and where I explain all the rules for the differentiation. Okay, so this one will be like you have to times it 12h negative 1, right? So 2. So which is dv by dh. We get here dv by dh. It's just here the 12h squared, right? I'm gonna substitute in here 12h squared times dh by dt. Okay, now we are trying to find dh by dt, which is here. We don't want this, we have to move this to the other side, right? So 36 over 12h squared equal to dh by dt. And then like 12, 1, 12, 3. We can cancel. And we are trying to find dh by dt, but we have this, we don't know the value of h. So we need the value of h. We will use this to find the h first in here. Okay, so I'm gonna write down v is equal to 500, and we have the formula for v here, which is 4h cubed. 4h cubed is equal to 500. So and then 4 will be divided. 500 divided by 4. H cubed is equal to 125. And then you're gonna find h. So cube root of 125, which is 5. Now we have the value of h. We just have to substitute it here. So I'm just gonna say when h is equal to 5, dh by dt is equal to 3, right? This is 3 over 5 squared. And then what they ask is, they don't say anything, right? So you can just leave it here, or you can change it to decimal, and you can use the calculator. Okay, so which is 0.12 cm per second centimeter, because it is hard. Okay, this is how you do the rate of change. First, you have to find out what it is given, what they say, and you can judge by the units also. You know, if it's cm cube or meter cube per second, cm cube per second, which is volume, right? They're talking about rate of change or dv by dt, or if they give you like cm squared per second, which is the area. So you have to find out what is given first, and then you have to. They will give formula. Sometimes they don't give formula, so they will just say the shape. You know, they will say it's a right circular cone. So you have to write yourself. Volume of cone is 1 by 3 by square h. So sometimes they give, sometimes they don't. It doesn't matter. You already learned the volume of cylinder, volume of cone, volume of sphere, right? Okay, so if they give the formula, you write down. If they don't give, you write yourself. And this one will be dh by dt. That's what they are asking. So you need to be careful when reading the problems. They say rate at which the depth is increasing. Okay, they were gonna say, or rate at which the radius is increasing or decreasing. So they write down first, and there is always a given information. So don't forget to write down first, and then use the formula and substitute the given value, and you will know what to find. And you find it here and substitute here, and then in this step you need the value of h, right? So h is like you have to use this, calculate here and substitute here, and you're gonna get the answer. Okay, it's not that hard. So I'm gonna explain more examples, so it will help you understand better. Okay. Okay, got it. So the volume of a right circular cone is increasing at the rate of 72 cm cube per second. Cm cube per second. Cm cube is volume, right? Volume, rate of change of volume. So I'm gonna write down first v equal to 72 cm cube per second. And then the height of the cone is always 4 times the radius of the base of the cone. Height of the cone, so I'm gonna write down height is always 4 times. So 4 times the radius, which is given. So that is given fact. First they give rate of change of volume, and then they say height is 4 times the radius. Okay, and then next one will be find the rate of increase of radius. When the height of the rate of increase of radius. So rate of change of radius, right? So dr by dt, because it is radius. For the rate of change, we always put t here. Sorry, I got wrong here. I have to write dv by dt. I'm sorry. And then dr by dt. So dr by dt is question mark. You wanna find that. And you have to they give find the rate of change or radius in centimeter per second to three significant figures when the height of the cone is 12 centimeter. Height is 12 centimeter. So h is equal to 12. Okay, let's do dv by dt here. dv by dt equal to, I'm gonna do with dv by dr because this one is dv by dr, not h anymore like the previous example. So dv by dt equal to dv by dr into dr by dt. Okay, so dv by dt is here 72, and dv by dr we don't have that, right? So I'm gonna do here, but they don't give the formula, but we can find it in the problem, which is the right circular cone. Okay, you see that the volume of a right circular cone. Right circular cone volume is 1 by 3 pi r square h. We have to run that by heart. So what we need here, which is dv by dr, right? So dv by dr, so we have to differentiate volume with respect to radius. The differentiation of volume with respect to radius, so which is here, but we don't need height here. We have to do it r. So I'm gonna plug in for r. I'm gonna substitute for r into height. Okay. So v is equal to 1 by 3 pi r squared times 4r. Then what happened? 4 by 3 pi r cubed, which is v squared. And then 4 by 3 pi cubed. Yeah, you have to differentiate the volume with respect to radius, right? So dv by dr is equal to 4 by 3 times 3 pi r squared. And then this will be cancelled. You get 4 pi r squared. That's dv by dr here. So I'm gonna plug it in here. 4 pi r squared into dr by dt. Okay, then you have to find dr by dt. So you have to, this is multiplying, you have to move it to the other side. It should be divided. 72 over 4 pi r squared equal to dr by dt. And then we have to find, we have to plug in h here, r value r here. Now we have only h, so we have to change it to r. So I'm gonna write down this first. H is equal to 12, and so h is the same as 4r. So 12 r is equal to 12 by 4, which is equal to 3. Then now we know that volume value of r, right? So I'm gonna substitute when r is equal to 3. dr by dt is equal to 72 by 4 pi times 3 squared, which is, you have to use a calculator for that. You will get 0. I'm gonna write down here 0.6366 cm cube per second. But the problem said 3 significant figures, so I'm gonna do this 3 significant figures. So you will get 637 cm per second. So that's how we do the rate of change. I'm gonna explain another formula, another example. So let me erase this. Okay, another example is the radius of a right circular pool of oil is increasing at a constant rate of 0.5 cm per second. So this one is the radius, rate of change of radius. Okay, so I'm gonna write down dr by dt is equal to 0.5 cm per second. And then you have to find in centimeter square per second 2 significant figures, the rate at which the area of the pool is increasing. So rate of change of area, because it's a rate at which area is increasing, right? So rate of change of area, which is dA by dt equal to question mark. And they give you when the radius of the pool is 200 centimeter, which is r is equal to 200 centimeter. Okay, now let's get to it. dA by dt. dA by dt is equal to dA by dr into dr by dt. I know use h here because there is no h, okay? So dA by dt is, that's what we are trying to find. I'm gonna write this down again. and dA by dr. dA by dr, we don't have that, right? We don't even have A. So A. What is this? Let's see. It's a circular pool. Circular pool, so which is circle. Area of circle is pi r squared. What we need here is differentiation of A with respect to radius, with respect to r. So I'm gonna just differentiate dA by dr equal to 2 pi r. Now we have dA by dr here, which is dA by dr. You see, we're gonna substitute in here 2 pi r dr by dt. Okay, so oh wait, sorry, dr by dt here we get this, right? It's 0.5. So we're gonna plug in 0.5 in here. So it's 0.5. And then we are trying to find this, that there's only one unknown value, which is r. So r is here. So I'm just gonna say when r is equal to 200 centimeter, dA by dt is equal to 2 pi 200 times 0.5. Okay, so you're gonna have to use the calculator for this one also, which is 628.3 cm squared per second. And they say two significant figures, so which is only here two significant 62, so it will be like 630 cm squared per second. Cm squared because in this area. Okay, that's another example. Okay, let me explain one last example. Let me erase this. The volume of a right circular cone is increasing at a constant rate of 12 cm cube per second. Okay, so now it's a cm cube per second, which is volume, for rate or change of volume, 12 cm cube per second. I'm gonna write that down, 12 cm cube per second. And then you need the radius of the base of the cone is always half the height of the cone. So radius is always half the height of the cone. So radius is half of the height that is given. And you have to find the exact value of the rate of increase of height. The rate of increase of height, which is dH by dt, equal to question mark. And then when height is 4 centimeter, h is equal to 4 centimeter. Okay, so we have to start with dv. Oh, why I'm always doing this? This is dv by dt. Okay, so dv by dt. dv by dt is equal to dv by dh into dh by dt. Okay, so dv by dt is here 12 centimeter cube per second. dv by dh we don't have. Okay, so I'm gonna write down the formula, which is right circular cone again. So 1 by 3 pi r square h. And then we have to find the derivative of v with respect to h, right? Differentiation of v with respect to h. So we don't want r here. So we're gonna plug in 1 by 2h into r, because r is equal to 1 by 2h. So 1 by 1 by 2h the whole square times h equal to v. And then you will have 1 by 3 is 3, stay 3, by 1 by 4, right? Half square is 1 by 4 and h square 5. Then you times it 3 times 4, which is 1 by 12 by h cubed. Now we are going to find the derivative of v with respect to h. Derivative of v with respect to h, which is 3 will be 3 will go down, pi, 3 minus 1 is 2, which is 1 by 4, right? Equal to 1 by 4 pi h squared. So we're gonna substitute in here, right? dv by dh, which is here 1 by 4 pi h squared times dh by dt is what we are trying to find, dh by dt. And then now 4 is you have to times here, so it will be 48 over this will be divided, right? Pi h squared equal to dh by dt. Okay, and then we have one unknown value, which is h, and which is given here. So when h is equal to 4 centimeter, dh by dt is equal to 48 over pi times h squared, which is 4 here, so 4 squared. So which will be 48 over 16 pi. And then what they ask is, they don't ask significant figure, they say exact value. So if you use the calculator on this, they will give you with decimal. So we don't want to do that. We just have to cancel out, sorry. So it will be 3, which is 3 over bar. This is high, right? ISO cm bar second. That's how we do the real chain problems using chain rule. Thanks for watching. See you in the next video.